Moving on to exercise 9.2. இதெல்லாம் ரொம்ப easy. Further போகும்போது தான் when you have to find the solutions and all, it is going to be a little difficult. அதுவும் கொஞ்சம் தான் difficult. இதெல்லாம் ரொம்ப easy. Okay? அதனால pay attention, do it slowly. Exercise 9.2. Question number 1. In each of the exercises 1 to 10, verify that it is a solution of the corresponding. So y ஒரு function கொடுத்திருக்கான். இத satisfy பண்ணுதா? Is it a solution? அப்படினா அர்த்தம் it is satisfying the equation equal to 0 ங்கிறது satisfy ஆகணும். Okay? Now, your y is e to the x plus 1. What is your y dash? E to the x or a derivative is going to be e to the x itself plus 1 is a constant. So when you differentiate it, the derivative is going to be a 0. Okay. Now I have y double dash, which is going to be again e to the x plus 0. 0 kadayadu. Okay. Now I have to substitute it in this equation. So y double dash in e to the x minus what is my y dash? It is again going to be e to the x, which is equal to 0. 0 equals 0. Hence verified. Very simple. Correct? Please copy. Question number 2. I have again y கொடுத்திருக்கு இந்த equationல satisfy ஆகுதான்னு check பண்ணனும். Can you see the equation? So this is the equation. You have to check to see whether it satisfies the equation. Okay? Now I have y equals x square plus 2x plus c. What is my y dash? It is going to be x square or the derivative is 2x plus 2x or a derivative is only 2. The constant comes out and I have plus c. So the constant it is again going to be 0. So இப்போ இந்த இடத்துல equation என்ன கொடுத்திருக்கு? I have y dash minus 2x minus 2 equals 0. So when I substitute what I got here, what did I get? Y dash is equal to 2x plus 2. And what do I have here? Minus 2x minus 2 equals 0. 2x, 2x போயிடும். 2 minus 2 போயிடும். So I have 0 equals 0. Hence verified. Okay, it is very simple. You just have to apply some brain. Okay, please copy. Question number 3. Y equals cos x plus c. இதை prove பண்ணணும். Okay, simple. Now I have y equals cos x plus c. Y dash equals cos x or derivative என்ன? It is going to be minus sin x plus 0. When I have y dash, sin இந்த பக்கம் வந்ததுனா I'll have y dash plus sin x equals 0. So this is this. Hence verified. Okay. Question number 4. I have y equals root of 1 plus x square. I need to prove that y dash equals xy divided by 1 plus x square. Okay, please pay attention to this question. I have y equals square root of 1 plus x square. Now I need to do y prime, y dash, which is going to be the d by dx of root of 1 plus x square. What do you know about d by dx of root x? It is going to be 1 divided by 2 root x. This is the derivative of root x. So now when I do that, I have y dash equals 1 divided by 2 root of, what is my x here? 1 plus x square by dx of 1 plus x square. So now you have 1 divided by 2 root of 1 plus x square times d by dx of 1 constant is going to be a 0 plus x square or derivative is going to be 2x. Now I can cancel the 2 and the 2 and what am I left with? I'm left with x divided by square root of 1 plus x square. So this is my y dash. And in that என்ன prove பண்ண சொல்றாங்க? I have y dash equals xy divided by 1 plus x square. Denominatorல square root இல்ல. அப்ப என்ன பண்ணலாம்? I see that I can multiply by square root of 1 plus x square divided by square root of 1 plus x square. So what do I have here? You also know that this is nothing but your y. Correct? From the question you see that root of 1 plus x square is going to be your y. So I can simplify this as xy divided by இந்த இடத்துல இது ரெண்டுத்தையும் multiply பண்ணா I'll have 1 plus x square. Okay, so y dash equals xy divided by 1 plus x square. Hence verified. Okay, hence what they have asked. Please copy. Question number 5. This is also very simple. So I have y equals ax. Y dash பண்ணா என்ன அர்த்தம்? A is a constant and x is the derivative. So with respect to x panna, constant remains. Okay, in that if substitute panna enna agum, I have x times what is my y dash? It is going to be a, which is equal to y. I have y equals ax. Again, what I have in the question, where x is not equal to 0. Hence verified. Okay, very simple. You'll get what you want. Okay, sixth question. Y equals x sin x and you have to prove this. So idhukku mela you need to use the product rule and all when it comes to derivatives. Okay, so I see that I have to do the derivative only once. In the y dash irukla adha paathe therinjukkanum ethana vaati derivative pananum appdi. Okay, now I have y equals x sin x. I need to differentiate on both sides. So in that I have u and v. So adu panalama. First u equals x, u dash equals 1, v equals sin x, v dash equals cos x. Correct? What is the formula? V u dash plus u v dash, which is going to be v u dash and sin x plus u v dash is x cos x. This substitute panalama. I have y dash differentiating on both sides. I have y dash equals sin x plus x cos x. So when I substitute it here, what do I have? X times y dash. So x போட்டுக்கலாம். X times sin x plus x cos x equals y plus x times root of x square minus y square. What is my y square? It is going to be x square sin square x. X square sin square x. Now, what do I have here? I have x sin x plus x square cos x equals y plus x times, in that x square na velila common edukren. So I have x square times 1 minus sin square x. I see that I have a square root here. In that in the x will come outside. X square comes outside and becomes x. And in that I have 1 minus sin square x, which is going to be cos square x. So square root kulle indha rendume velila vandaduna, what will I have? I'll have y plus x square times cos x. Correct? And here I'll again have x sin x plus x square cos x. You understood what I did here? In the x square term velila vandaduna, it becomes an x and it gets multiplied with this x. So adala x square aichu. Cos square x square root out velila vandaduna, it will be cos x. So what is my x sin x here? I see that it is y from the question. So my LHS is going to be y plus x square cos x, which is again y plus x square cos x. Hence proved. Hence verified or proved or whatever you want to write. Okay, LHS equals RHS. Clear? Please copy. Question number 7. I have xy equals log y plus c. This prove panano. Y dash equals y square divided by 1 minus xy. So now this is my LHS. LHS first differentiate panona. What will I have? I have u equals x and v equals y. U dash is 1. V dash is going to be y dash. What is the formula? Vu dash plus uv dash. In the formula, so now I have differentiating on both sides. The LHS becomes vu dash, which is going to be first the line and vu dash and y times 1 plus uv dash is going to be xy dash. If I substitute panna, I'll have y plus xy dash equals, when I differentiate the RHS, log y over derivative in y 1 divided by y, but I again have dy by dx. So it is going to be y dash. You have d by dx of log x is going to be 1 divided by x, but since you have a y here, you have to find the derivative of y also. Okay, clear? Plus derivative of a constant is going to be 0. Now when I multiply the y to the other side, I'll have y square plus x y dash equals y dash. Okay, taking this to the other side to club the y dash terms, what do I have? Y square equals y dash minus x y dash. So either in the y dash y square equals y dash times 1 minus xy. And what is my y dash? It is going to be y square divided by 1 minus xy. And this is what is needed. Correct? This is the needed, and the denominator cannot be a 0. So 1 minus xy not equal to 0. So I have xy not equal to 1. Correct? Proved. Hence verified. Please copy. Next question, 8th question. I have y minus cos y equals x. Or in the bakko, this prove panna. Y sin y plus cos y plus x times y dash equals y. Okay, this prove panna. Now I have y on this side. So when I derivative on both sides, find the different derivative on both sides. Y dash minus cos or derivative is going to be minus sin y. But remember, you have y. We are differentiating with respect to x. Anala you always have a y dash. Okay, don't forget. Equals derivative of x is going to be 1. Okay, clear? Super. Now what do I have? Y dash plus sin y dash equals 1. When I club the y dash term, I'll have y dash times 1 plus sin y equals 1. For y dash and I'll have 1 divided by 1 plus sin y. Correct? I'm going to substitute this in the question that is asked. Y dash badala substitute panna pora. So what will I have? When I take the LHS, what do I have? y sin y plus cos y, y sin y plus cos y plus x. What is my x? It is going to be y minus cos y times 1 divided by 1 plus sin y. So this is my LHS, correct? So if in the I see that the cos y and the cos y terms are getting cancelled. What am I left with? I have y sin y plus y times 1 divided by 1 plus sin y. So this is my LHS. When I take the y outside, I'll have y times sin y plus 1 times 1 divided by 1 plus sin y. Sin y plus 1, no, 1 plus sin y, so I can cancel these two terms. You see that they are in the, you see that they are in terms of product. So what am I left with? Y, which is my RHS, I think. Correct? RHS in y from the question. You see? From the question, the RHS is going to be y. So this is my RHS. Hence, verified. Romba simple. Please copy. Question number 9. X plus y equals tan inverse of y. Okay. So first tan inverse derivative d by dx of tan inverse y is going to be 1 divided by 1 plus y square. But remember you have y and y dash. This is the first year. Okay. Now differentiating on both sides, d by dx of x is going to be 1 plus d by dx of y is going to be y prime equals tan inverse of y derivative. So I have y dash divided by 1 plus y square. Okay. Now I need to get this in terms of this. So the multiply panalama motama. So what do I have? I'll bring y dash to one side first. So what do I have? I have 1 equals y dash times 1 divided by 1 plus y square minus 1. In the y dash in the pakam vandudina, I'll have a minus 1. Correct? So now this is 1 equals y dash times, taking LCM on both sides, I have 1 minus 1 plus y square, the whole divided by 1 plus y square. You see that I have a minus here, so I am putting a bracket. It is very, very important. Bracket podlana motama sodapulano. Okay, now I have 1 equals y dash times 1 minus, now I am multiplying the minus inside. So 1 minus 1 minus y square, the whole divided by 1 plus y square. So in the 1 and the minus 1 will get cancelled. So what am I left with? I have 1 equals y dash times minus y square, the whole divided by 1 plus y square. Okay, now let us multiply this to the other side. So I have 1 plus y square equals minus y square y dash. What is he asking? You have y square y dash on this side. So I am bringing it to the other side. So I have y square y dash plus y square plus 1 equals 0. And I think this is what is asked. Y square y dash plus y square plus 1. So hence verified. Okay, please copy. Question number 10. I have y equals square root of a square minus x square. RHS prove pannanom. X plus y dy by dx equals 0. So finding the derivative on both sides. What do I have? Y dash equals, in the pakkam derivate panna, what is the d by dx of root x? It is going to be 1 divided by 2 root x. Correct? So the derivative is going to be 1 divided by 2 root of x, which is going to be a square minus x square. But remember, you have to differentiate what is inside also. So a square minus x square. This you differentiate panna, then the next step. So y dash equals 1 divided by 2 root of a square minus x square times what is inside the bracket. A square is a constant. So minus x square differentiate panna, I'll have minus 2x. So when I cancel the 2 and the 2, I'll be left with this. So now I have y dash equals minus x divided by square root of a square minus x square. What is my square root of a square minus x square from the question? Square root of a square minus x square is simply y. So this is nothing but y. So in the other substitute panna enago, I'll have y dash equals minus x divided by y. When I multiply it here, multiply the y here, I'll have y dash equals minus x. Bringing the x to the other side, I have x plus y dash equals 0. Y dash na anartham x plus y dy by dx. However, it is asked in the question, I have changed it to that form. So dy by dx equals 0. Where y is not equal to 0. Y 0 achna enagum differential equation poidum. So y not equal to 0 is also important. Hence verified. Okay, please copy. Question number 11. The number of arbitrary constants in the general solution of a differential equation of 4th order. So 4th order na enna. So I have first order, second order, third order, fourth order. Usually 4th order if we represent panna matom, you write it like this. கரெக்டா? So இப்போ ஒரு fourth order derivative இருக்கு அப்படின்னா, so when you get to y to the third order, what do you have? You have something plus c1. இப்போ இதுல இருந்து திரும்ப y double dash போச்சுனா you will have something plus c1, c1x plus c2. இப்படி இருக்குமா? Now when I come back to first order, I'll have something plus c1 x square plus c2x plus c3. Correct? Now when I come back to the actual function itself, I'll have something plus c1 x cube plus c2 x square plus c3x plus c4. Correct? So how many constants do you have? 1, 2, 3, 4. அதுதான் கேக்குறாங்க. The number of arbitrary constants in the general solution. General solution னா எப்பவுமே இந்த c எல்லாம் இருக்கும். கரெக்ட்டா constants இருக்கும். Which is basically a variable. Constant னா என்ன அர்த்தம்? அதுக்கு என்ன வேல்யூ வேணா கிடைக்கலாம். So that is going to be your general solution. Of fourth order, the answer is going to be 4. Okay, but when you see the next question, the number of arbitrary constants in a particular solution. Particular solution na enartham? You will not have any constants. So it is going to be a 0. Okay, particular solution na enartham? Whenever you find the derivative, இப்போ 4 la ஏதோ ஒரு something இருக்கு அப்படின்னா, y third derivative, which is going to be y triple dash, you will have something plus c1, for which you will substitute the value of 5o, illa you can substitute the value of 15, or you can substitute the value of 200 or anything. So this is not going to have a general solution. It is going to have a particular solution, and you see that this constant gets erased. Okay, so there are no constants. So the answer is 0. Okay, in that the answer is 4. Enna order irukko and order number of constants complete irukko. Okay, so with this we are done with exercise 9.2. If you have any questions, please comment in the comment section below. Vera doubts kekkanuna neenga Instagram la engitta kekkalam. Okay, thank you so much. Bye.